All right, can you hear me? Okay, good evening, everyone. All right, so can you hear me? All right, so we are going to start. Once you have any questions, feel free to ask them in the chat. I'll do my best to try to get back to respond to you. All right. So I'm sure by now most of you have installed the necessary things for the Python programming. Alright, so I'm sure by now you've also installed the Visual Studio Code that we'll be using as the IDE, and also created your first repository. So feel free, once you write any code, upload it to your GitHub repository, and then always use that to back up your code. Okay, so today let's see what we'll be looking at. I'm not sure we'll be able to cover everything in 1 hour, but we'll do our best. So wherever we stop, we'll continue next week. All right, so we're going to look at variables, then operators, conditions, and conditional statements. And then maybe if we still have time, we'll look at data structures, loops, and then functions. Okay, so because this is a lot, we may not cover everything in the 1 hour that we have together, but anything that I'm not able to cover here, I'll cover it in the next class, which we'll have next week. Okay, so what are variables? So you can think of variables as containers that hold a value. So basically you can think of it almost like a bucket, and the bucket will hold some values. The value will have some kind of data type, and so some of the primitive data types we have in programming will include integers, floats, boolean, and so on. Okay, so when you have the need to store values and then reuse these values later on in your code, usually you will need to use a variable. Okay, so variables, their values are not fixed. That means that as the program runs, the values can change. So for instance, if you have in your program where age equals to 16 and age is the age is the variable and 16 is the value that is stored inside the container age. So at some point the age may be 18, or it may even decrease to 15. Okay, so because it can change, we call it a variable. But when we have containers that store values that don't change, we call them constants. Okay, so for Python, the way you will write your variables, you will write it in lowercase letters, and then if you have maybe the name of the container is more than a word, then you will use the camel case. So that means you start with lowercase, then the next word will have will start with an uppercase. Okay, so we can access the value stored in a variable based on the variable name, and then use that in our program, which we will see later. So for example, here we have a simple program. where we have a variable called message. So in the message variable, you can see here that we have a string hello world, hello Python, and it's being stored inside message. Okay, so we are storing the string hello Python into message. So anytime we print message, we should get hello Python. So in your labs, I would like you to try this out, and then you print these two. You print message, and then you print message plus message to see what happens. Okay. Then you can also have this example where we store a name in a variable. So the name that is being stored in the name variable now is called David. It's called Dave, sorry. And so this print should be in lowercase. So remember I said Python is case sensitive. So this should be in lowercase. So I'll correct this in the notes before I share it with you. Okay, so I would like you to try this as well during your labs tomorrow. You print I am plus name and see what comes out, which should be I am Dave. And then you can also try to print I am comma name, which should also be I am Dave as well. So you see that I've used the name variable twice. We have it on this line and also on this line. So we don't need to repeat Dave here. Anytime we need to change the name, we can just change it from here, and then it won't affect the rest of our code. That's why we have variables, so they are very useful. Okay, so we have here another variable, which is the string. The area of the classroom is, okay, that's a variable called message. Then we have another variable called length, which stores 50 as its value. Then another variable called breadth, which has 35 as its value. So you can try this when you print message length times breadth. Okay, you should get the area of the classroom is whatever that is. Yes, Samuel. So in Python, you don't need to use anything to define your variables. You just put the name of the variable and then you can assign it and use it. So in JavaScript, you can use let, yes, but in Python, you don't need to use let. Also, const, in some languages, they allow you to use const, but const is not for variables. Const is for constants. So in Python, how you would define constants is that you would define them similar to a variable, except that this name of the constants will be capital letters. So I may show you an example of that later, or maybe in the labs. All right. So I hope you've gotten clarification somewhere. In your Python code, you don't use let or const or any other keyword to declare your variable. You just give it the variable name, and then you can assign the value that is going to hold. The variable is going to hold. Alright, so these are more variables, and this time these variables have different data types. So you can see I've used comments to tell you the data type for each of them. Alright, so age is an integer, height is a float, so a float, course underscore code. So this is another way for our naming convention. You can separate each letter using the underscore, but everything will be in lowercase. Alright, so this is another way you can use it. So course underscore code, and that is a string literal. Alright, Then we have address as well, which is also a string. But you will notice that address is a multi-line string. That means the string takes more than one line. So in this case, you see address takes two lines. So two lines. So in Python, you have the option of using multi-line strings, and this is an example here. Okay, so once you print all of this should work, but you will notice that we don't have a variable called cost. So when you try to print it, you get an error. So I'll correct it in your notes. What you need to put here is cost underscore code. You try to print cost underscore code, and that should print this message. Alright. Then in Python, you can also try to get the type of the variable using the type inbuilt function. Okay, using the type inbuilt function as you see on the final line. So you can print it. So print type and then cost underscore code, you should get string literal. If you put print type underscore age, you should get 16. Integer. Alright, because that's the type. So this type inbuilt method can let you determine the types of your variables. So that can be very useful for you. So that's a hint to help your programming journey. Okay, so for your labs, I want you to try this assignment where you will write an assignment statement to save a phone number into a variable. So you can give your variable any name, okay, but let it store a phone number, and then you can print it and see what you get. So I'd like you to try this exercise. As you can see here on slide 7, you try it in the labs tomorrow. Okay, so we can reuse our variables like I said earlier, and that's one of the advantages of declaring your variable, is that you declare it once and then you use it as many times as possible. It's also possible for you to do another assignment somewhere else in the code to override the initial value in the variable. So sometimes you may need to do that. Okay, so you can try this as well. You store something into a variable and print it this way. So print x, comma x, comma x, comma x, and see what you get in the labs tomorrow. So variables are reusable, and if your variable names are short like this, of course it saves you time of writing, repeating all of this when you need to reuse your variables. Okay, so your code may be shorter. Alright. So another example for reusing variables, you see this time I have a variable called num, which is storing an integer with the value of 3. And then elsewhere, I can replace the value of num with num plus num, okay, which will give us 6. And then I can even replace it again with num times num. So I want you to try this exercise and see what you get in the labs. Alright, but you can also guess in the chat what you think the final value of this will be. So when you print num, what do you think the final value will be? So I'll give you some few minutes. Let me hear from you in the chat what this value will be. Alright, so any guesses? as to the value of norm. Okay, someone says 9. All right, any more guesses? Someone says 36. All right, so let's look at this. Someone says 6 and 9. All right, so look at this now. On this line here, norm is 3. On this line here, we have 3 plus 3, which is 6. Okay, so here norm is 6. All right, and then here we have 6 times 6, so norm should be 36. So the two people that guess 36, I think you're on the right path. So once you try it, you will see what you get. And then I would like you also to, as much as possible, play around with these codes. As you write them, play around with them, um, change certain things in the program and run them again and see what you get. Okay, so once you understand how a variable can be built on itself, that will be critical for you in many of the applications that you end up writing. Okay, so try to see what these things can be when you change the value, and then try to increase your understanding. All right, moving on. So operators, we have some operators in Python. Okay, some of the operators that we have in Python, many of them work with 2 operands, and there are a few that work with just 1 operand. So these are some of the common categories of operators we have in Python. We have arithmetic operators, comparison operators. We use them to compare relationship between 2 different entities. Okay, we have assignment operators as well. We have logical operators. They can also be used in conditional statements, as you will see later. And then we have bitwise operators. Okay, so this table here shows you some of the arithmetic operators we have in Python. You will see that there are many of them on the list that you may already be familiar with, like the plus, minus, division, multiplication. You've all seen that before, but maybe you've not seen these ones like modulus. Okay, so modulus, basically what it does is it returns the remainder of the division. So the remainder of the division is what it returns, and this is how you use it. 9 mod 2. Okay, so you know that 9 divided by 2 is what? 4. Okay, that's what you get when you do 9 divided by 2, 4. But the remainder of 9 divided by 2 is 1. Alright, because 2 times 4 is 8 plus 1 will give you 9. So this is the modulus operator. You can think of it as the remainder operator. Okay, it gives you the remainder of this mathematical operation. Then we have exponent. Exponent just means to the power of. So this is 2 to the power of 3. Okay, and this is how you write it with double star. Okay, you use double star to write the power or exponent. You also have floor division. All right, so this is how you write it with double slash. So I will allow you to try that floor division in your code and see what you get. All right, so try the floor division in your code and see what you get. Okay, then for your comparison operators, we have equal to, and you will notice that the equal to operator, when you are trying to see when two entities are the same, you use the double equal to symbols. You don't just use one. If you are using one equal to, that means you are referring to assignment. You are trying to assign what is on the right hand to the left hand. Okay, so what is on your right hand side, you are trying to assign it to what's on your left hand side. That's when you use one equals. But when you use double equals sign, and you are referring to the equal comparison operator. So you can use this in your conditions, like your if condition, to check if two things are the same. So in this case, we want to check if x and y have the same value. All right, so we're checking to see if the value stored inside variable x is the same as the value stored inside variable y. Then we also have the not equal. So not equal to, you can use the exclamation mark and equal, or you can use the less than greater than sign. So you are testing to ensure that these two variables are different. The values stored in them are different. Okay, so you can try that to see what you get. Then I'm sure you are familiar with the rest. Greater than, you are checking to see if what's on the left hand side is greater than what's on the right hand side. And then less than, we check to see if what's on the left hand side is less than what's on the right hand side. And we have greater than or equal to, we are checking to see what if something on the left hand side is either greater than or has the same value as what is on the right hand side. And then for your less than or equal to, you are checking to see if what's on the left hand side is less than or is the same as what is stored in the variable on the right hand side. Then we also have the assignment operators. Your assignment operators, you can see them, they are like short forms of this other statement. So we have the add and assign. Basically what that means is that you do the addition first, then you assign. So if you check this example out, what you are doing with this x plus equals y is that you are going to add y to the value of x and then assign that value that you get as a result of the addition to x. Okay, so this is the same thing as saying x equals x plus y. Okay, so you can think of this as a shorthand. So this is the short form of this. Okay, then we have subtract and assign, the same thing. So you once you write it like this, basically what you mean is this, that you want to take x, you want to take y away from x, and then you want to override the value of x with that result. The same thing for your division and assign. It's the same thing as saying x divided by y, and then you assign the value to x. The same thing with this as well. Y star equals y. Basically what you're saying is you want to multiply x times y and then assign the value to x. Alright. And then your mod as well. So you can do mod, get the modulus and then assign. So basically you do x mod y to get the remainder, and then that remainder you use it to replace the value of x. Okay, and once you write, you can do the same thing for your exponents. So you can get the exponential value of something and then assign it to override the variable on your left hand side. Okay, so this will be the same thing as saying x to the power of y, whatever value you get override x with it. All right, and then your floor division as well as that as well. So you can do x and then get the floor division of that value by y, and then you override the result you get from this operation to uh, to what is stored already in x. Okay, so hope you are with me so far. We have also logical operators, and with logical operators I will give these three for you to look at. We have and, or, and not. Okay, so and means that these two variables on the left hand side, or whatever conditions on the left hand side, need to be true for the statement to be true. For or, you just need either one of them to be true for the statement to be true. If both of them are false, then your statement will be false. Okay, and then you have not, and not works with one operand. Okay, basically what it does is it inverses whatever is here. All right, so if this is true and you do not true, what you actually get is false. Okay, all right, so all right, so Samuel, I'm not sure if we have that in Python. In JavaScript we have it. I'll have to confirm. Okay, because usually we have that triple equal to in JavaScript, but I'm not sure if that is also in Python. It's in some languages, so you just have to try it in the lab and see. Okay, usually the triple equal to has to do with identity. You're checking to see if two values are the same. All right, so it usually works on their data types as well as the values. That's why they use the triple equal to. All right, so just try it in your lab to see if you have that variable. All right, so conditions and conditional statements. So that your program is not too predictable, you may just need to use conditions, and conditions can apply to the inputs that you get from the user to do different types of things. So yes, Nampan, I've answered the question. I'm not sure if we have this triple equal to in Python. Okay. Okay, I'm not sure if that is in Python, but it is available in JavaScript. All right, and in JavaScript, basically what it's used for is to test both uh, the type and the, what do you call it now, the data type and value. All right. Okay, so for the logical or, let me go back to that, the logical operators. So for the logical operators, and is only true if both of them are true, and then or only one of them needs to be true for that to be true. If both of them are true, then it's still true. But if both of them are zero, then you get zero for the OR operation. I hope that's clear, Bits, Mr. Bits. Okay, so moving on to conditions and conditional statements. Um, we use these conditional statements to handle conditions. So sometimes you need your code to make decision based on inputs or maybe based on something else. It will need to branch off and make a decision, or it will branch off based on a decision that it makes. Okay, it will be clearer once you see an example. But for the conditions in Python, we have the if statements, the if else statements, we have the if elif statements, or you can have the if elif and else statements, or you can have nested if. That means that the if has other if conditions inside. So let's look at an example. If you are talking about the if statement, this is the structure. Remember, in Python we don't have the use of semicolons and then the curly braces to define our scope. So what you do is we use the colon. All right, so you write your condition. So if, the keyword if, then your condition, and then colon, and then the statements that are under this if condition, you have to indent them. All right, so remember to indent. You can use two spaces, you can use two spaces, you can use 4 spaces, or you can use tab. All right, so any of them is allowed, but make sure you are consistent in your code. And if you are writing code with other programmers, you need to decide on your coding convention what you want to use, whether you use 2 spaces, 4 spaces, or tab. So an example of if statement you can see here, we have a variable called age, which we assign 25 to it, and then we are checking if age is greater than 18. All right, then you see our colon. So the condition is surrounded by the brackets. We have our keyword if, and inside this condition you can see that we're checking to see if age is greater than 18. So I hope we remember what the greater than operator is. Yes, you've seen it as one of the, do we remember where we saw it? The greater than operator. Okay, so you can refer back to some of the previous slides to see what operator the greater than is. All right, so we'll print this is an adult once this condition is true, and then we come out of the condition statements, the condition block, we come out of it, and then we print the program continues here. So in your labs, I would like you to try this program and see what you get. Then try to reversing this condition. Use the less than and see whether you will still get this line or not. Then you can add other lines under the inside this if block to see what you get as well. So try all of that and more in your labs tomorrow. Okay, now the if and then else statements. So this is the structure. You have an if, the if keyword, and then your condition, and then you have your colon, and then in the block you put your statements, whatever that is. All right, then you have the else keyword, and then its own colon and then a block of code. And this else is going to only work when this condition here is not met. Alright, so once this condition is met, the interpreter will only execute this and then leaves the else block alone. But once this is not met, this condition is not met, we won't do anything here. We'll just go to else and do these things here. And you can see an example here. Age equals 15. We're assigning the value 15 into age. So if age is greater than 18, is this going to work? Or do we print this? I would like you to try that in the labs. So try this in the labs and see what you get, and then play around with the conditions. Maybe the value, or you reverse the operator here and see what you get, or you increase or decrease the age and see what you get as well. Okay, so that's the if else statement. We either do this or we do this. You do one, no, you don't do both. Then we have the if elif statement. So for the if elif statement, basically what happens here is that as you see in the example, I'll need to update here, is that we have two conditions, one in the for the if and then one for the elif. And so for the if, we check to see if this is met and then we do this. And then the elif, we check to see if this is met and we do this. And mind you, we only do one of this. The compiler or interpreter will only execute one of these blocks of code. So if this condition is met, it will do this and then leave the others. But if this is not met, then to check this condition to see if it's met. And if this condition is met, then it will now do this. Alright? And that's how it works. So if an elif is okay in Python programming, you don't need to force an else statement. Okay? Alright. Then we have the if, elif, and then the else statement. Okay? So the if, elif, and else statements, basically if this condition in the if is met, then you do what is in the if block. Else, you now check what is in the elif, and then if this condition is met, you do what's inside this block. And if nothing else is given, you just continue. Okay, so in the code, in the way the interpreter or the compiler will work is that it will check this condition. If it's not met, it will check this condition. If it's not met, then it will do this. All right. But if either of these condition is met, it does that. So if this is met first, it will do this and then ignore the rest and jump to another part of the code. Okay, now I would like you to try this in the lab and then play around with this value. Okay, maybe change the age to 18 and see if this block of code works. The other thing to note is that you can have as many elifs as possible in this structure. So here we have if age is greater than 18, then we have elif if age is equal to 18. You can have another elif where you check if the age is equal to another number or greater than another number. All right, and then have its own statement inside, or set of statements inside that. So that is allowed. So you can have inside the if, elif, and else statements, you can have many elifs blocks. Right, you can have as many elifs as your program needs. Okay, so the only thing you need to be careful of here is that the first condition that is met is what is going to run. So if your code is in such a way that the variable meets the two conditions, the compiler is only going to work with the first one that it meets. So make sure that you're very careful with the way that you structure your if and elifs and else statements. All right, or your if and elif statement, because the condition is cease first, that matches is what is going to work for, and then it will skip every other thing else. So if it's this condition you want, right? So just make sure you've structured your if and elif in such a way that it doesn't match this, right? It should either bring this first and then this later, or you do it in such a way that it doesn't match this and then it match this. So just be careful when you're using your if and elif statement. Then we also have our nested if statements. And for our nested if statement, basically what happens is that you can have an if statement which has another if statement as its child, which has as many if statements as it needs. So that's what we call nested. Okay. So when we say something is nested, so that means something is inside something. So in this example, you see that we have two if statements. This if statement is checking country, and this if statement is checking state. So you can see that this is tabbed, right? It's under the same indentation as this statement. So that means that it is a child of this if block. All right. So I hope we understand everything up to here. Okay. So sometimes in your code, you may, for example, want to check if a variable is a certain country. Then you want to check for the state and so on. So there are certain times that you may have nested if. All right. So that is fine if you have nested if statements. So, and the nesting can go beyond 2 steps. All right. It can be as many as you need. I would like you to try this example in the labs and see what you get. What happens when you run this program? What happens? Okay, so run this program and see what happens. This is a comment. All right, so your ticket price initially is 1,500. If it is less than this price, this is what you should get. Otherwise, this is what you should get. But I want you to print what happens when you raise the price. What happens? Okay. The other thing you will notice when you run this code, you will see that this is a unique code for a character that we are all familiar with. So I won't tell you what that character is, but once you run the code, you will see what character that is, so that subsequently you can use that for your other programs. Okay, so this will be a useful Unicode for you. All right, so for the Unicode, this is how you will display it. You have to put the U before the quotation. All right, and then inside the quotation /u, and then the 4 hexadecimal numbers that represent that particular symbol. Okay, so this is how you use that in Python. So run this in the labs, see what you get, let me know. Then I want you to also try this and see what the output is. You notice that the price here now is 1,600, and then we have if, elif, and else. I want you to check whether it prints the desired statement. Also, you will note that in the slide, there are more spaces for the tabs here. That's an error. All of them should have the same amount of space. So I'll correct that before distributing the slides to you. Okay, so that you can try that. Okay, then I want you to try this program as well and see whether you get the desired output. So you can see here inside this program we have 2 elifs. Okay, one to check for price equals 0 and one to check for price greater than 1,500. So I want you to try all of this and see whether you get the desired output, whether the output you get made any logical sense. Okay, so I think this is where we'll stop, because once we start talking about data structure, there's a lot more that we'll need to cover, and then we don't have more time. Okay, so hopefully in the next class we'll cover data structures, but I want you to practice all that we've seen so far on the variables, the operators, and then the conditional statements. All right, and play around with things that we've not also discussed in the class. Use some operators that we've not talked about with some variables and with their different data types, and also combine them with this if and elif and else statements to see what you get. Also try play around with nested uh, if conditions. You can do nested if and nested if and else statements too, to see what you get, and then you let me know. So try all of that in the labs tomorrow. So this is where we'll stop for today, and then subsequently um, we will cover the other things like the data structures, and then the other things that we will need to see in Python. But I want us to go slowly. All that we cover in class, just practice it and see what you get. If you are still having a problem installing Python, VS Code, getting your GitHub account, speak to your other colleagues that have done so. All right. And if you still have problems even after speaking to them, then see how you can contact me so that I can help you during one of the labs that I'll be available for. All right. So I think this is where we'll end the lecture for today. I wish you all a pleasant evening. Thank you.